The arm consists of three main parts: elbow joints, forearm link, and wrist assembly with two grippers. In the bottom section are three control elements: two knobs to rotate joints and one slider to control the gripper. Before I go further, I need to explain that all positioning and sizing is done within CSS. Look, the styling uses CSS variables to maintain proportional sizing, ensuring the arm scales smoothly across different screen sizes. Properties like border radius create rounded edges for a more mechanical appearance. Absolute positioning allows precise placement of each segment to its parent. Absolute positioning is the backbone that makes this robotic arm movement possible. Without it, the rotations, connections between segments, and overall mechanical behavior would completely fall apart. Absolute positioning uses the nearest positioned ancestor as a reference. This creates a kinematic chain. Look at the HTML structure. This is important. Such parent-child relations link elements to each other, allowing all this to work as intended. All sizing and positioning is done in the CSS to minimize the size of JavaScript code, leaving it only for rotation and grippers movement. Now to the JavaScript. The handle knob rotation function manages all the rotational logic for the arm's joints. When you press down on the one of the circular knobs in the footer, it captures your initial mouse position and creates a reference to the knob being rotated. As you drag your mouse, it constantly calculates the angle between your current mouse position and the knob's center point using the math_attan_to function. This function implements several techniques. It normalizes the rotation angle to stay within a clean -p to p range, applies physical constraints to limit how far the forearm can rotate, and smoothly updates both the visual knob rotation and the corresponding arm segment's position in real time. The handle gripper function provides completely different behavior. Connected to the slider control, it translates the input value into vertical movements of the two gripper claws. The top gripper moves downward, while the bottom one moves upward simultaneously, creating a pinching motion. The function automatically calculates the maximal possible movement based on the wrist assembly current positions. Dimensions, ensuring the grippers never move beyond their physical limits. When the page first loads, the initialization routine carefully positions all components by setting their transform origins and default rotation states. The elbow and forearm are both configured to rotate around their left ends to simulate realistic mechanical joints. The link to the file's location is in the description. I will scroll the whole HTML file now. That's all for now. Have a nice one.